So in this video, we're going to go through the extra review pages at the back of your packet. So in this case, we're looking for number one, which proportion in relation to the triangles is not true. So if I fill in my missing angles, I'll able to see that these are similar triangles. And so I'm going to go through and say A and R match, B and S match, and then C and T match. So it has to be true that the ratio, so for example, AB over RS would have to be equal to BC over ST, which would have to be equal to CA over TR. And likewise, if you flipped it the other way around, RS over AB would have to be equal to ST over BC, which would have to be equal to TR over CA. So we can use this to sort of narrow our options down. So AB over RS, so that would have to be equal to RT over AC. Excuse me, this is saying that's equal to RT over AC, which if I look at my key, is right away incorrect. But let's just go through the other ones just to double check. So BC over ST is equal to AB over RS. That's true. Also equal to AC over RT. And then AB over AC is equal to RS over RT. So that's not in my key, but if I want to look, right, here are the two ratios that have that. RS over AB is equal to TR over CA. If I cross multiply, AB times TR is equal to AC times RS. I can actually write this now as AB over AC by dividing by AC and then dividing by TR. I can actually get that proportion. So this is also true, although a little bit trickier. So it is not true that AB over RS is equal to RT over AC, because if you look, these are the wrong pairs of triangles. So if we look at number two, so if we want to find the lengths of x and y, it says to write an explanation. You can just solve. I'm not going to be super picky. In terms of review, if it was the exam, you would have to sort of explain that the sides would all be in proportion because they are similar triangles. So you could set up a proportion as such to find y, which would end up being 4. And then similarly, 3 over 6. Actually, no, it would not be 3 over 6. It would be 3 over 9 because you're looking at the entire length. So this is the two different ways you can use side splitter, which would be also be 4, actually. Interesting. Cool. So you're using the side splitter theorem in two different ways. Again, you would need to write this out. Claudia would have to use the proportion of both triangles, one using the cut sides, one using the entire side, using the side splitter theorem. Okay, so now this is another one about proportions. So they didn't give you any angles labeled, so you have to go through and say that these are vertical angles, so these are going to be congruent. And then if you have parallel lines, you know that these two are congruent because they are alternate interior. So then if I wanted to go through and write out my corresponding triangles, I know that ACE is similar to BDE. And now I can write out sort of my keys from the proportions because I know that they're similar. So AC over BD is equal to CE over DE, which is equal to EA over EB. And, the order can be flipped for these two. So let's look. CE over DE is equal to EB over EA. This one so far does not look correct. Let's check the others. AE over BE, so we're looking at this guy, is equal to AC over BD. That is correct. EC over AE, so we don't have that written, so I'd have to solve. So we have EC and ED, and then we want to see if we can solve that for EA, EB. So this is going to be similar to the last problem. So this is how you can sort of see that the Regents really does not come up with new problems. It's kind of the same year after year. So I want to move the AE over. So you'll end up with EC over AE is equal to EC over AE is equal to okay, so this is also giving me a bit of a head scratch because EC over, I'm getting the opposite as well. So I have to go through and double check. And then, because it's asking which one is true. This is where Mr. Sousa does not read. So that makes it even easier. You just have to find which one is true, so you're just using the key. That's it. This is why you guys need to read. I need to read as well, because otherwise we make our lives very difficult and yeah, no. Okay. The sides of a triangle have lengths of 12, 16, and 21. An angled bisector meets the side of length 21. So you know that this entire length is 21. Find the length of x and y. We should be used to this by now, but you have to be able to write y in terms of x, or x in terms of y, if that's what makes you happy. So these two together add up to 21. So then y by itself is equal to 21 minus x. So there's a couple different ways you can write this proportion. You can say x over 12 is equal to 21 minus x over 16. Or you could say x over 21 minus x is equal to 12 over 16. And of course, your order can be flipped. You could put this whole line on the bottom and vice versa. So I'm going to use this one. So let's do 16x when I cross multiply. And now again, when you're multiplying by a binomial, you need to distribute. So it's x times, it's not x times, it's 12 times 21 minus x, where the 21 minus x is in parentheses. So 12 times 21, which gives me 252 minus 12x. Add 12x to get 28x equals 252. And we get that x is equal to 9. And we know that y is equal to 21 minus x. So y is equal to 21 minus 9. So y is equal to 12. Those are your two answers. Just checking to see how much more. So for these, when you see this sort of setup with two right angles, you should immediately write down the following two things because this is your checklist. You're looking to see which one of these you're going to use to set up your proportion. So here we're given information about x, which is the altitude. So I know that I'm going to use the altitude one. So side over altitude is equal to altitude over side. So in this case, right, they give us the entire length is 25. I really just want to know what this piece is, so I can just do 25 minus 9 to get 16. So now I can fill in, my side is 9 over x equals x over 16. Cross multiply, x squared is equal to 144, which when you take the square root, you get that x is equal to 12. Now looking at this one, there's no information given to me about the altitude, so I'm going to use hypotenuse over leg equals leg over side. So the hypotenuse of the entire triangle is 25. Its leg is x over 9, x squared, 25 times 9 is 225. Take the square root to get that x is equal to 15. So again, as soon as you see two right angles in a triangle, write down these two things. Figure out if you're given the altitude, you're setting up this proportion. If not, you're setting up this proportion. Given the diagram to the right, and DE is parallel to FE. DE is parallel to KL, excuse me. Find FE and FL. Okay, so because of this, right, so first let's mark our thing. So we know that these two are congruent because they're vertical angles, and these two are congruent because they're alternate interior angles. So you have to look and say what is corresponding to what. So because these sides are opposite, 4 over, let's call this one x, x is equal to 6 over 15. Because if we're doing new, original, so now we cross multiply and solve. 15 times 4 is 60. When you divide, you should get that x is equal to 10. So now I'm going to use the same sort of proportion to solve for y. So we have y over 12 is equal to 6 over 15. 6 times 12 is equal to 72, equals 15x. 72 divided by 15 which is y is equal to 4.8. So in the next one, we're given a pair of parallel lines. So I can right away say that this is a pair of similar triangles. Now, if CB is equal to 3, CA is equal to 10, and CE is equal to 6, what is the length of ET? So here we're doing the split over, so like the top over the bottom. So we want to know, we have 6 in x, because x is what we're solving for. 3 is the top. The bottom in this case is going to be 7. So we have 3x is equal to 42. 42 divided by 3 gives me 14. Okay, so again we have parallel lines. If AE is 3, ED is 6, and DC is 15. So this is kind of the opposite of what we were doing before. So instead of doing the top over the bottom, we're looking for the entire sides. So 3 over 9 is equal to x over 15. 9x equals 45. Solve to get that x is equal to 5. Last one of the review is a proof. So given that we have perpendicular lines and a pair of congruent angles, prove the triangles are similar. So we're going to use angle, angle. AC is perpendicular to DB, so AC and DB form a right angle in both of these triangles. And then angle A is congruent to angle DEC. So all we need to do first write your givens. Again, you can write this all in one line as long as you state all of the important things, that perpendicular lines form congruent right angles. Therefore, the triangles are similar because you have two pairs of corresponding congruent angles. And that is the end of the review for this test. Use the review sheets, use the quizzes posted online, use all of the resources, go back, try problems again, make sure that you're able to do all of the learning targets based off the exit tickets to make sure that you're all prepared for this test.